Okay, everyone, so now we're going to talk about some functions like the medium and the range of a function, okay? And if there's a limit, there's some kind of existing limit, because if the limit is infinite, then there's no limit, right? Infinity is not considered the limit. But we're going to talk about these functions. For example, it's better to show it than to talk about it. Let's see here. For example, function f of x equals 1 divided by x as x approaches infinity, right? So what is that going to be? Well, it's just going to be 0, because you see, as this number here approaches a very large number, it's just going to be 1 divided by 1 trillion, quadrillion, decillion, you know. I think it's called non-Italian something, undecillion, something like that, which is 20 or maybe 1 trillion to the 20th or something. So as this number becomes very large, this is just going to approach 0, okay? As this number becomes very small, this is going to approach infinity. So if you have a graph, so as this number becomes very small, approaches 0 from the right, which is a positive thing, this is going to approach infinity. And as it approaches positive infinity, this is going to approach 0. So you got a graph kind of like this. Just a sketch. This doesn't go up, okay? This always goes down, and it gets closer and closer and closer to this line, but never touches it. And so here it gets closer and closer and closer to the vertical axis, but never touches it. As this number becomes very large in negative infinity, it's going to approach it's going to approach 0, okay? But from the negative side, as it becomes very small, close to 0, as x becomes very small, close to 0, I'm just going to erase this stuff in here. As x becomes very small, close to 0 from the left side, from the negative side, this approaches negative infinity. So you got a function kind of like this. You know, and you can see that there's a symmetry here on about the origin, about this part, okay? And this is typical of odd functions. So it's like an odd function's f of minus x equals minus f of x. And you can see, replace this x in here with minus x. What are you going to have? 1 divided by x negative, right? 1 divided by minus x equals, what is f of x? Well, just put an x in here, and that's what you have. But you got a minus here, so you copy this minus here, and look at that. Minus 1 divided by x equals minus 1 divided by x. This is just high school math. So you can see that this is an odd function. Yeah, we're talking, I think the topic of this class is limits as x approaches 0 in negative infinity, or as x approaches an asymptote in infinity, okay? Negative infinity, positive infinity. Now, there's a general rule, like a guideline. If the numerator, okay, you have a bunch of x's here, like x to the 4th plus 3x cubed plus, you know, maybe minus 2x squared minus 7x. You have something like this. That's the numerator. And the denominator has an x with a power larger than the largest power in the numerator, like for example 5, or anything else, you know, larger, maybe 4.2, you know. As x approaches infinity, I'm going to put a 5 here. As x approaches infinity, this is going to approach 0, because it doesn't matter how much this grows, okay? In fact, in the numerator, what you got to care about is both in the numerator and the denominator, what you got to care about is the largest power, okay? Why? Because you see, what you can do here is divide the whole thing by the largest power of the fraction, okay? Which will be x divided by 5, for example. So what do you have here? You have something like, well, maybe, yeah, divided by, let me think. Yeah. Oh, well. Yeah, you can divide it by x divided by 5, but I don't know. Maybe x divided by 4. So if you divide everything by x divided by 4, you're going to have 1 plus 3 over x, okay, minus 2 over x squared. You're dividing everything by x to the 4th. So 1 plus 3 divided by x minus 2 divided by x squared minus 7 divided by x cubed. All this divided by x. Okay, now as x approaches infinity, so this is going to approach infinity. This is going to approach infinity, so you have 3 divided by infinity, so this goes to 0, minus 2 divided by infinity squared, so this goes to 0, minus 7 divided by infinity cubed, this goes to 0. So what do you have in the end? You have 1 divided by infinity, which is just 0. Okay, so when you have a denominator with a whose largest power is larger than the largest power in the numerator, so the denominator has the largest power and this largest power is larger than the largest power in the numerator, the whole thing is just going to go to 0. Okay, in this case here you have x to the 5th, which is larger than anything that the numerator has, so it's just going to approach 0. If the powers are equal, kind of like if the powers are equal, like x to the 4th, the largest power in here is the same as the largest power in here. The fraction as x approaches infinity is going to be the division of the coefficients. So you got a 1 here, yeah, or the coefficients that follow the largest power, okay, the variable with the largest power. So you got a 1 here and a 1 here, so 1 divided by 1 equals 1. If you had, for example, a 4 here, okay, it will be 1 divided by 4. That's what it was going to approach as x approaches 0. All right, now let's just say that the numerator has the largest power of the numerator is larger than the largest power of the denominator, for example, x cubed. So now you have an x cubed here and you have an x to the 4th. As x approaches infinity, this whole thing is just going to approach infinity. All right. So let's see, for example, 3x squared divided by x squared plus 1. Now, you want to find out, I just told you this is going to be 3 because it's 3 here divided by 1 here, and that's 3. But let's divide everything by x squared, okay? So this is going to be 3 divided by 1 plus 1 divided by x squared. What I'm doing is dividing every term by x squared. As x approaches infinity, this term in here approaches 0. So what do you have? 3 divided by 1, 3. See? As x approaches infinity, it's going to be that. As x approaches, well, I'm sorry. You guys can't see this here. So, as x approaches infinity, it's going to approach 3 here, right? But because the x on top and the x at the bottom are even negative infinity is going to turn this to positive infinity. So, as it goes to x negative, it's going to be positive here and it's going to be positive here, so it's still going to approach 3. See? So it approaches 3 to the right and to the left. Find the limit of 5 minus 2x squared as x approaches infinity. Just going to be 5, right? This is going to approach 0 because it's infinity squared, and 2 divided by infinity squared is infinitely close to 0. It's never going to be 0, guys, but it's going to be so negligent that it's practically 0. So it's going to be 5 minus 0, okay? That's the limit. Limit of this as x approaches infinity. Here we go again. 2x minus 1 divided by x plus 1. Okay, so this is just going to be 2. I'm going to show you guys why. Divide everything by x. So 2x divided by x is 2. Minus 1 divided by x is minus 1 divided by x. X divided by x is 1. Plus 1 divided by x is 1 divided by x. As x approaches infinity, this approaches 0 and this approaches 0. 2 divided by 1, 2. I'm going to show you the graph of this function. Okay, here. Now look at that. As x approaches infinity, okay, this think about these two here, 2x and the x, not the minus 1 and plus 1. So this is going to be a positive infinity divided by positive infinity, but you got 2 positive infinities divided by an infinity, so it approaches 2, okay? And it is approaching 2. You see this horizontal dotted blue line here is the asymptote, horizontal asymptote, where y equals 2. So this is gonna approach 2, okay? It'll keep going like this. And it'll keep approaching. It's never gonna cross this line, but it'll just keep approaching. Now, let's see. As x approaches negative infinity from, for example, x equals 2 is going to be one thing. Well, let me think here. You know what? I think let me see here. Right. I was just thinking about something else. So let's just say the x is 2. Okay, so 2, look at the denominator. 2 plus 1, 3. Well, let's just say that x is 0. 0 plus 1, 1. Now let's just say that x equals minus 1. Minus 1 plus 1, 0. And here on top, at the numerator, you have minus 1, so minus 2, minus 1, minus 3. So it's going to be minus 3 divided by 0. Okay, so it can never be a minus 1. X can never be minus 1. Otherwise, you're going to have something like this. Minus 3 divided by 0. Alright? And that doesn't exist. So, it can never be minus 1. Okay? Now, from the negative side, well, let's just say that x approaches infinity. Negative infinity. Okay, so it's going to be negative infinity here. It's going to be like this. Minus 2 infinity minus 1, which doesn't matter, okay, because this term in here is so huge that the minus 1 doesn't make any difference whatsoever. Divided by negative infinity, right? Because, yeah, plus 1, but forget about the plus 1. So you got a negative divided by a negative. This is a positive. Okay, so twice infinity divided by infinity, you could cut these two, all right? You can't actually, according to literature, you can't do that, but in your mind you can. So as 2 approaches negative infinity here, this way, it's going to approach 2, and it is approaching 2. Look, it's approaching this line here, okay? All right. Now let's just say as it approaches 0 from the I mean, it's not approaching 0, it's approaching -1. Okay. So you have, for example, let's just think this: -2 times -2 is going to be -4 -1 divided by like -2, yeah, -2 divided by -2. Okay. Now as this gets very close, well, let's see, for example, let's say that x equals -1.1. So -2.2 minus 1 divided by -1.1 plus 1, which is -0.1. And this here, okay, 0, just pretend this is a 0. And then this here is -3.2. So you can see that here you got a negative and here you got a negative. These are going to become positives. Okay. So you have 3.2 divided by 0.1, which is 32. So you can see that as it approaches 1 from -1, as x approaches -1 from the left being negative, okay, -1.1, -1.01, -1.001, but never crossing 1, it's gonna approach infinity, and that's why it goes up there. Okay, it's going up there, and here it's approaching 2. Now, I'm just going to show you a bunch of other functions. That you know that this is going to approach 0, right? Because I don't know if I keep doing this. The last time, I'm going to do it for the last time. Divided by x. You know why I don't divide it by x squared? Is because I don't want to just have a 3 here, okay? Or we can do that. Let's divide it by x squared. So dividing everything by x squared, you got 2 divided by x plus 5 divided by x squared over 3 plus 1 divided by x squared. Let me just, yeah. Sometimes I got a real problem writing a 5. I don't know. Okay, so as x approaches 0, infinity, this is going to approach 0, this is going to approach 0, this is going to approach 0. So what do you have here? This whole thing in here approaches, it's not equal, okay? It approaches 0 divided by 3, which is 0. So you can see here you have the numerator with a power of 1 and a denominator with a larger power. The largest power of the numerator is 1 and the largest power of the denominator is 2. So this is going to approach 0. Okay, now let's try another one here. 2x squared plus 5. There you go, the 5 again. 3x squared plus 1. So it's x squared. Just take the coefficients of the x's with the largest power because they're equal. So this, as x approaches infinity, this approaches, not equal, approaches 2/3. And you got another one here, which is 2x cubed. Here we go, plus 5, okay. 3x squared plus 1. Okay, the numerator has a larger power than the denominator. Numerator has a cube, and the denominator has a square. So this is just going to approach infinity, or it could approach negative infinity. Okay, let's see here. Well, it's just, I'd say that as it approaches infinity, yeah, it's going to be infinity. let's see, as it approaches, x approaches infinity. Okay, so this is going to be positive, and this is just going to be, doesn't really matter. As x approaches negative infinity, I say this approaches negative infinity because x cubed is going to be negative infinity. So you have, okay, and then you have, so you got a negative here because negative infinity cubed, negative infinity, times 2, negative infinity. And here you have something that's an infinity too, but it's squared. So if you really want to go slow, just divide everything by x cubed. So you got 2 plus 5 divided by x cubed divided by 3 over x plus 1 divided by x cubed. This goes to 0. This goes to 0. Okay. This goes to 0, and you have a 2 in here. So you have this approaches 2 divided by 0. But there's something here. Let's just analyze this calmly. Okay. Yeah. Say there's a negative infinity. Yeah. It could be approaching. Yes, it approaches negative infinity, all right. Okay. As x approaches negative infinity, you see, this is going to approach 0, but because it's 3 positive divided by a negative, this is going to approach kind of like minus 0, okay? And here's the same thing. You got a negative infinity cubed. A positive 1 divided by negative infinity is going to be like a minus 0. So you have a very small negative number here, okay, in the numerator. You got a very small negative number. Let's put minus 0 here. And now you got a 2, okay, plus a very small negative number here. But because this number, this negative number is very small, you can put like a minus 0. Now you got a 2, okay, which is way larger than a negative 0. So forget about this thing. This is still going to be a positive number. It's going to be like 1.99999, but it's going to be a positive number. And then you have a very tiny number, which is negative here. So you got a positive with a negative. This approaches negative infinity. I'm going to show you guys the graph of this function here. Okay, 2x cubed plus 5 divided by 3x squared plus 1. In fact, this doesn't come from the book. This image here, okay, I'm doing it here. I'm going to put it here. So you see 2x cubed plus 5 divided by 3x squared plus 1. This is something that I use the software to make. So you can see that as x approaches positive infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. So, yeah. I'm gonna delete this. Maybe another example, because they say more the merrier, the more the merrier. 1 divided by x squared plus 1. Okay, so as x approaches negative and positive infinities, doesn't matter because it's squared, it'll be positive. So this is going to approach 0. Okay, this is going to approach 0 from the positive side, not from the negative side. And look at this. This is the graph. Okay, now what I'm trying to say, what do I mean by approaching 0 from the negative side? It could be this. It could be approaching 0 from the negative side, like that, okay? But it's not. It's approaching 0 here from the positive side. So, guys, I think for today It's fine, you know. Let me think here. I'm thinking. I'm just looking at something here. Hold on. Go to the restroom. Restroom break. I think that'll be it for now. I'll continue this on the next video.